Okay, we're doing an example problem about a pool, and we were at U0 equals 700, like we have 700 grams of chlorine going into the pool. U sub n equals U sub n minus 1 times, what goes in there? 1 minus 0.3, 30% decay. Actually looked it up on the internet. 30% decay rate for the chlorine in the sunlight. And of course it depends, how shady is it, how sunny is it, but that's a good number to use. Then we go plus, what did I say, 50? All right, now what's the long term? Well, you can put it in the calculator and then just go look at like U sub 50 or U sub 100 or something. And I want to make sure people know how to do that, because I know it's good to know how to do it by yourself, but like without the calculator, but you also are going to have a calc for most of these problems. And it's smarter to check it with the calculator. What if you just forget a negative sign or something when you're dividing your two numbers? I want to make sure that you can do this with the calc. So this one started with 700, so I need a 700 right there. And then it had a 30% decay, so I'm going to go up in here and make this have 30%. And the last problem I did had divided by 12 in there. I don't want that in there. So 0.30. Then I'm just going to delete out a few of those. And then I was doing plus 50, and delete out whatever else was in there. There we go. And now if I go to my table, oh, it's going to run forever. You know how to break this? How to stop it? You hit the on button. Stops it from thinking. And it makes it break, it's called. Because if it's in that loop, it can sometimes take forever, because I had a table settings. You might want to look at your table settings. Make sure it's not crazy big, because that'll get you locked in that loop. All right. Did you guys figure out about where it started to level off? U sub what? 50? 60? 400? What I'm asking is U sub what? U sub 10? U sub 20? Give me close anyway. U sub 40-ish, okay. So I'm going to go table settings 40. And now I'm going to go to my table. And this one's label A. Is it leveling off at all? 4, 5, 6. Oh, is this, it's an E thing. Okay. So these numbers are going up. Okay, something's wrong. U sub n minus 1 times 1. See if you can find my mistake. It must be in here somewhere. Ah, it's a plus. And if it's a plus and a plus, do you get how it would be going to infinity? All right, so I screwed up my plus sign right there. And that's the kind of thing you'll have to do if you're doing your test. And hold on just a second here. Again. Okay, got that fixed. And now I'm going to go to my table. And there we go. Looks like it's leveling out at about 166 and 2/3, 166 and 2/7. Okay, what does that mean in the context of our pool? Here's a typical question for you. In the context of our problem, what does the 700 mean? Starting value, starting amount of what those? Chlorine. Okay, good. Next one is, in the context of our problem, what is that called? The decay rate. And in the context of our problem, what's that? How much chlorine you're adding every period of time is the only thing that's safe to say. Because it kind of depends on how you set up the equation, whether you set it up for yearly or weekly or whatever you set it up for, that's the equation. We do not go in and mess with these as far as like divide by 12. All right. So the answer of 166 is how much, in 2/3, at 6, 7, is how much chlorine will be in there over the long run. All right. Now, do you remember how to set these so that if I say, oh, well, that was not good, because you're supposed to have a long run value of 200. Yes, you could guess and check with this number forever until you finally found it, or there's a smart way. How do I set it equal to 200? The long run value, not this number. What number do I put there? I don't know, so I put an X. Where do I put the long run value? Yes, sir. Both of them, you're right. So if I want this to be 200, And this is also 200. Why? Because if you look at your chart, if you think about it, and you look at these values on the chart, this is like U sub n, and this is like U sub n minus 1, and they're all like the same in the long run. All right, so final answer on that. So this ends up being 140 right here. So I'm going to subtract 140, and I'd have 60 equals x. All right, good. All right, let's say there's a no calc part of the test, and there is. What's the long run value for this one? Now write down what you think I should do, and then actually do it with your hands, no calculator. A lot of you zeroed in on this and this, and that's good because you remember how in the long run that first number is not going to matter. Okay, so final answer, 20 divided by 0.5, which is not 10. 20 divided by a half is the same as 20 times, flip it, 2. So that's equal to 40. The long run value of this puppy would be 40. Any questions about that? All right, now let's do loans and investments for a while. This is another really important topic that you're going to need to know for your test tomorrow. All right, so imagine for a moment that you took out a loan of $200,000 to buy a house. That's a pretty typical situation. That's actually a kind of a smallish house around here. It really depends on what area of the country you live in. If you're on the island of St. John, you can't get a house for less than, well, put it this way, an average house is about $1 million there. But they all have amazing views of the ocean and stuff. So, and in some parts of the country, like in downtown Michigan, you can get houses literally for $1. Why on earth would somebody sell you a house for $1? Because they had so many houses that were inhabitable. This is a house that's like almost falling down, and your agreement if you buy it for $1 is that you will fix it up so that it's livable. And they had all these houses that were going to have to just be bulldozed over, and neighborhoods that were going to just be wiped out, and they wanted to have that fixed. So the city owned them because the people had given them up, and so they were selling them for $1. There's others that actually people owned and just wanted to get out of them so bad, they were selling houses for $1,000, just like normal, no requirements even. Just here, buy my house for $1,000. But it all depends on where you are. So we're going to go with $200,000 loan. Hopefully you've already written this. Now, write me the rest of this formula if I give you the situation. The loan is going to be for 5% monthly with a payment of $2,000. 5% monthly with a payment of $2,000. Now turn me and show it to me, and I'll tell you if you've made any little mistake or not. I'll pause for a second. On the test, some of it's as simple as write the formula, and most of you had this right. 1 plus 0.05 divide by 12, very easy to forget, and then minus 2,000. Why is that not plus? Because you're paying off a loan. Loans will have a minus there. If you start with $200,000 loan, you want that balance to go down because you want to pay it off. All right. Now, I'd like you to look on the table and tell me where, at U sub what, does this thing get paid off? And remember, that's in months. Yes, ma'am? Good question. Will this always be an addition on a loan or investment? And the answer is yes. Here's why. Interest is really the key. If there's interest charged, there's no such thing as negative interest. So this has to be a plus if there's any interest involved, and any loan or investment problem will have interest. That's why it's a plus. All right. So put it in your calc. Now you're looking for U sub whatever where this thing gets paid off. I'll pause for a second while you do that. Okay, I just told my calculator to calculate it out to U sub 130 because that seems about right for how long it'll take to pay this thing off. I know you won't know that. You just have to try it. All right, so I'm in the negative numbers. That means I went just a little too far. Oh, there it is. Look at that. 129 payments got me to there. But that is a really common wrong answer. Because think about it. Is it actually paid off? No. When it hits here, then it's actually paid off. And even better than that, what's that negative 742? They owe you $742 back. That happens in the real world. If you overpay your loan, they have to pay it back to you. They can't just keep it and say, hey, they were stupid, paid us extra. They have to send it back to you. Same with insurance companies. If you overpay them more than they are supposed to have, they have to send it back to you, even if it's only like 50 cents. All right, so final answer is 130 payments is what it took. Not 129, 130. And those are monthly, right? So 130 months. So how long did it take? You'd say 130 months. You don't have to get tricky and say that that's 13 years and a month or whatever. Don't worry about that. It's 130 months. Okay, how much did you pay for the loan? 130 months. You paid how much each time? Another really common mistake is to just say 130 times 2,000 because that's 260,000 and it's not factoring in one little thing. They owe you 742 bucks back. So then you take that and subtract the 742 bucks. I'm fine with you rounding to the dollar. So then it's 759,258. Do I have that right? 759,000. Sorry, it's 259. That's a 2. 259,258. Is that right? Okay. So then that means that's how much you paid total for your house. Now this next part is really important. How much did you pay in interest? It's really not that complicated. You thought you were going to pay 200 for the house, 200,000. You really paid 259,000. So what's that extra 59,258? So you subtract off the 200,000 you were expecting to spend, and that extra 59,258 is interest. 59258. Would all of those be easy for you? All right. I'd like you to write another equation for me. Write me an equation for, stay with me, a loan of, actually no, let's do an investment because that'll be a slightly different equation. Write me an investment of $300 a month for the next 40 years, starting with $0 and getting 9% interest. I'll say that one more time. $300 a month for the next 40 years, which would be 40 times 12 months. And you get 9% interest compounded monthly. If one of them is monthly, the other one will automatically be monthly. If the interest payments are compounded monthly, then your payments have to be monthly payments. All right, here is the formula for it. And I just realized I forgot an important part of the formula that would have cost me half a point on the last one. U0, I started with nothing. UN minus 1 times 1 plus, if it's interest, it's always plus, 0.09 divided by 12. Then I need a plus, because this is an investment, 300. But what did I forget? Cost me half a point. N is greater than or equal to 1. Remember that little domain thing? Yes, if you're writing out the domain. It can't even put it in the calculator. But this is an example of something you can do on paper that you can't do on your calculator. You need to be able to identify the domain. So if you don't have that, there goes a half a point on each of those problems. Okay. Now, I asked you to figure it out at 480 months. I'm going to go in here, and I'm going to change this to a 9% compounded monthly, 0.09 divided by 12, end parentheses. Then I'm adding $300 a month to it. And I go down here and I started with 0. Now I'm going to go to my table settings. You want to see something cool on table settings? If I want it to be 40 years, I could go 40 times 12 right there. See? 40 times 12, and I hit enter, and it figures out it's 480. So right in the middle of the little computer program, I can type in my multiplication there. Okay, then it takes a while. You go to table, and it's going to grind and grind and grind. And you already got the answer? Is it over $1 million?
Yeah. $1,404,000.
$1.4 million. Now I want you to think about that. Most people have a work life of about 40 years. If you come out of college at like age 22, and you want to work to age 62, which is pretty typical retirement. Some people retire later than that, like 65 or 67. Some people retire earlier than that, like 58. But let's say 62 is right in the middle of retirement. 40 years is what you're going to be working. You want to be doing something you're enjoying too, because 40 years, holy cow. All right, so 40 years, that's a lot of money. $1.4 million? Holy smokes. Only $300 a month. $300 a month isn't that bad. Some people pay that for cable. Seriously, if you have cable for 40 years at $300 a month, and you had invested it instead, you'd have $1.4 million. Think of it that way. Isn't that insane? That would probably be cable with every possible buy add-on thing, you know, like NFL and all of the super expensive stuff. Every pay-per-view that ever comes on. Anyway. Okay. $300 a month, though, is way less than a car. Can you imagine a person who lived in a city making the choice to, I'm never going to buy a car? I know we live in the suburbs here where you just like everybody has a car, but you can actually live your life out completely without a car and be just fine. Especially if you're in a city that has transportation. You know, you can ride bikes too. Nothing illegal about riding a bike, even in the wintertime. Especially if you're down south in a city. It wouldn't be that hard to live without a car. People that need a car sometimes just go rent them. It's only like $50 a day to rent a car. To buy one, it's like 20 grand. So you can rent a car quite a few days. Point is, what if somebody decided, I'm not going to ever own a car. I'm just going to save that money that I would have paid for my car. Easily be a millionaire. Easily. Okay. And a lot of kids think millionaire is only because I started my own business and had to be a genius and blah, blah, blah. No. There's lots of people that don't make that much money, but just are really careful about always never touching that nest egg that they're building up and letting it grow. Some people would argue, wait a minute, you're telling the kids 9% in the stock market? That's what it's averaged for the last 50 years. Some people are making dire predictions about how it's going to not be good for the next 50 years. Who knows? Maybe it'll be the best time ever to invest. Maybe for the next 50 years, it'll be even better than 9% interest. You'll have even more than $1.4 million. All right. So I just wanted to make you think about investing because it's something you can do. Like you could start right now if you wanted to and never touch it. Let it grow, grow, grow. One more thing. I want you to do the same exact scenario except of an investment, except this time we're not going to add anything to it. Go back to your y equals. We're just going to put in $100,000. You might be thinking, oh, nobody has that. Well, some people do. You may not have it right now. But if you had $100,000, which, by the way, isn't near enough to even pay for your college, unless you go a really, really cheap place. Your $100,000 that you put into an investment right now, this is what a fairly famous guy named Ben Franklin did. He put a bunch of money into an account, and then he said, I am leaving this to you, City of Philadelphia, except you can't touch it for 100 years. He said, I'm giving you my $100,000, but you can't have it for 100 years. And after it's done compounding for 100 years, then you can start spending it. Let's just see what would happen to $100,000 at the stock market's average of 9% over the course of a long time, 100 years. Not use of 100, that's 100 months. 100 years. So I'm going to go out to table settings. And you remember that trick I just showed you a second ago? If I want 100 years, it's 100, 100 times 12. That's month 1,200. All right? And if you think in terms of like the length of time our country's been around, 100 years isn't even that long. I mean, our country's been around 200 years. There's countries over in Europe that have been around, well, some of them, China could argue probably 3,000 years, isn't it? Something like that. It's in the thousands anyway. So 100 years isn't even that long. You might be thinking, that's ridiculous, but it's in the course of history, it's not that big of a deal. So I'm hoping to be one of those people that leaves a gift like this. I got to try to figure out how to make it work. So I want to leave a gift like this, and I want to leave it, I think what I'd like to do is leave it to my future descendants. So like, there'll be 25 grandchildren someday, or maybe it'll be great-great-great-grandchildren who will inherit this. And I'm not saying I'll have $100,000 to put in there. I don't know how much I'll do. But it obviously is going to be a very big number. It's still grinding, still crunching. Anybody got their calculators done already? You must have the fastest calculator in the room. Nice job. Okay. Now, let's make sure. Does it say that EE thing? Okay, so 7, 8, 3, and then what?
5, 4, 8.
All right. So $783 million. So if I had 783 descendants, they could each have $1 million. Wouldn't that be cool? You wish your great-grandpa had done that? What if I only have one descendant then? It's $783 million. All right. And that's only 100 years. That's 100 years. I know 100 years is a long time. And, you know, many of you will not live 100 years from now, but some of you will. Some of you will. The advances in technology and stuff today, some of you would be still alive 100 years from now. I want you to remember this day that your teacher talked about this. Because you're 15, that'd make you 115. I know it seems really old, but there's a lot of oldsters living to 120 nowadays. Yeah. Like the oldest people in the world, they typically live to around 120. There's some undocumented cases of people like 129, but 120 is not common, but I'm talking about for like the oldest person that in the state of Minnesota or in the United States, it's going to be like 120. Okay. Enough talking about that. Let's do one last very specific problem, and I want to actually score this one so that you can have a realistic feeling for how you're doing. I'm going to give you a problem. You're going to put it in the calculator. Listen, listen. You're going to put it in the calculator, and then you're going to answer 3 questions about it. Stop. Talk to him more in a second. Let me get my problem out. All right. Here's the loan. It's a loan for $22,000, which is approximately the price of a new car nowadays. Depends on the type of car, but that's an average new car. $22,000 loan. It's going to be at 7%, and you're going to make monthly payments of $800. My 3 questions are this, and I want you to write them on your iPad so that somebody else can grade them in about 2 minutes from now. You're going to be typing this into your calculator. If you want to get going on typing it in, you already got everything you need to make a formula. A is, when is it paid off? Like month 137? Whatever it is, you figured out. Number 2, or B, sorry. B is how much total did you pay? And part C is how much interest? I'll pause for a second while you crank that one out. Okay, so we're grading this thing now. When is it paid off? Was it 31 months it was completely paid off? All right, and that's the first answer is 31 months. Part B, how much total did you pay? Well, if you paid for 31 months times, what was it again? How much of payments? 800. Then that's 24,000. Hold on. 24,800. But that would be wrong because you have to factor in that amount they owe you back. If you look at the table on line 31, they actually owe you back $750.60. So minus 750.6. If you rounded that to 751, I'll be all right with that. 24,000. I'm going to round it to 751. And how much is that? 49? Oh, 49? Unless they rounded it. Don't worry about the rounding here. 24,049. Raise your hand if your person had that right. Okay, good. And then the last question, how much interest did you pay? You simply subtract the 22,000. So if I subtract off 22 grand in my head, that's pretty easy. I can get $4,049 of interest. $2,049 of interest. So much for my head being accurate. Should have used the calculator. Okay. Give them a score out of 3. 3, 2, or 1, and then head back to your seat. All right. How many of you had a 3 out of 3? Raise your hand if you did. Awesome. Who only missed 1? Raise your hand if you only missed 1. Okay. Now, if you had a bunch wrong, you know you have work to do tonight then. Your homework for tonight, listen please, is just a Schoology quiz. Do the Schoology quiz that is posted. It's one Schoology quiz to rule them all. And it's due tomorrow. Okay? There'll be no in the darkness binding either, so.